Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
We'll begin our intro to variables, arrays, and operators section by first talking about variables. So what are variables and how we can use them? And that's what we'll discuss in this section. The next section we'll be talking about the different types of variables available to us. Then we can move on to arrays and finish up with operators in the fourth section. So, what exactly are variables? Well, without getting into the nitty-gritty details, I want you to think about variables as basically a way to associate some sort of a value with a name. So, variables are a way to associate a value with a name. While this isn't necessarily a very technical description, it's an easy way of thinking about variables and how to use them moving forwards. So, for example, let's say we're building some kind of a game. Well, maybe we need to keep track of the player's position, so we would store the player's current position in some variable perhaps called player position. Then as the player moves about, we would constantly update player's position, so that variable value would change according to where the player currently is. Now, in order to create variables and use them throughout the code, we have to follow a certain naming convention which changes from language to language. In Java, it looks a little like this. So, variable naming convention. Okay, so it begins with some sort of modifier. So we won't really cover modifiers yet, as we need to introduce a concept of classes to deal with that. Then there is a type, then there is a name. Then if we're assigning a value right away, we use the equals operator, and then whatever value the variable takes on. And then of course we end with a semicolon. So in Java we have to end every statement with a semicolon, otherwise we get errors. And actually that's a very common source of errors, is we might forget to add the semicolon at the end, and that can really screw up the rest of the code. Now let's go through each piece one by one, starting with the modifier. Well, actually we'll cover the modifier in a different section, so modifier will be covered in a different section. Okay, we'll need to learn about classes before we can take a look at that. The type is used to declare what kind of values our variable can take on. So, used to declare what type of values our variable can take on. And I guess, you know what, I'll use the word kind instead of type, as that's what we're defining here. As for the name, we have pretty free reign to name our variables whatever we want, but typically we want to name the variable a name such that we know exactly what it is and what it will do. And also, variables are typically nouns, so they are object words. So we don't usually want to name a variable something like run, because that's an action. Those will save for methods. So for the name, make sure name describes what the variable is used for. So coming back to the player position example, well, if we have a variable called player position, it's pretty clear exactly what that variable is going to do for us throughout the code. It's going to hold the position of our player. So we want to make sure these are nouns, and we use camel case. So what I mean by camel case is typically the first letter is non-capitalized, and then for every word included in the name, we want to capitalize the first letter of each word, so like we see in saved instant state here. As for the value that our variable can take, so value, this depends entirely on the type of the variable. So for example, if we have some kind of a numerical type variable, we can't pass it in a string or a true or false value. So this depends on the type of variable. We'll talk a little bit more about types in the next section, and actually that's what the entire of the next section is going to be devoted to, but for now know that there are 8 primitive types, although we can define many more types to fit our needs. So let's talk about 2 important processes that have to do with variables. These are declaration and initialization. So if you take a look at our example up here, well, this step here is called the declaration, in which we declare a type of variable and a name. And then this part here, in which we have the name of the variable equals and then some value, that's called the initialization. So the declaration is used to give a variable a name and a type, and the initialization is used to give a variable name a value. So for example, we could have the type and then the name and then the semicolon here. And for our initialization, we would have the example of the name equals value. Okay, so this can be broken up into two steps in which we declare the variable first, then later assign it a value, or we can do this all in one line, as we saw here, where we have the declaration and initialization happening at the same time. Now, if we don't explicitly initialize our variable, usually Java gives most of at least the primitive types a default value. So we'll talk a little bit more about that in the next section. As a brief example of a declaration and initialization, I'm just going to quickly introduce an integer type variable. So integers are basically whole numbers, so no decimals. And so we're just going to start an integer. I'm just going to call this I, okay? And let's give it the value of 5. Okay, so right here we've done the declaration and initialization in one step. So in 2 steps, in fact, I'm not going to comment this out. I'll just show you what it would look like in 2 steps. We could have int I, and then I equals 5. So these are essentially performing the same task, this line here, and then these 2 lines, but we'll find that we'll use both ways of doing things throughout the code. So I'm just going to get rid of that. Now, as the name variable might imply, we can change the value of it once assigned, simply by selecting the name or typing the name of the variable and then giving it a different value. So for example, let's say I want I to equal 10. I can do that by calling I and then set that equal to 10. I could not, however, assign this a value that's outside of its type, so I couldn't assign it, say, a string value such as hello. This is going to give me an error because we've explicitly declared I to be of type integer. Another thing we cannot do, and actually let me just comment this out and explain why. So cannot assign a different type to an already declared variable. So another thing we could not do is we could not then create another variable called I. So for example, let's say we want another integer I to use in a different place in the code, and we want to assign this a value of 20. Well, this is going to give us an error because it's saying I is already declared and defined up here. So I'm just going to comment this out, saying cannot redeclare a variable. That being said, of course, we can reassign the value unless a variable is declared final. So for example, if we have another integer, int j equals 10, and we declare this to be final, then that means we cannot change a value of j. So j is final and its value cannot be changed. So for example, if I set j to be equal to 20 this time, we're going to get an error again saying that j is final, and so we cannot change its value. So I'm just going to comment that out, and I'm actually going to move this down to here. Now, I just want to point out one more common mistake before we move on to our next section, which is going to be describing types, and that is assigning a variable another variable's value. So we have our integer I. We first declared it to be 5, then we initialized it from 5 to be 10, we changed its value. But now let's say we want to change it to j's current value. So let's say j is actually equal to 20, and we want to assign I to have j's value. We couldn't do it the other way around because j is final. So what we could say is I equals j. So as long as these 2 variables are of the same type, they're both integers, this is perfectly valid. And what this means is that I takes on j's current value. Now what this doesn't mean is that I will always be equal to j. That means these aren't actually pointing or referring to the same variable. So let's just pretend that j is not final, so its value can be changed. If I then changed j's value to 100, I would not be changed to 100 as I is set to be j's current value in this case. So we're not setting them equal to one another, we're just setting I equal to j's current value. Okay, so let me just write a comment for that. So we are not setting these two variables to be the same. We are just saying that I currently, and let me just add another line, contains J's current value. Vice versa, J does not take on I's current value unless it's on the left-hand side. So basically, when we're assigning a variable a value, we assign the variable name on the left-hand side, and then we assign the value it takes on the right-hand side. Okay, so that's your basic intro into what a variable is and how to use it. So basically we can change their values unless they are final, and then use them throughout the code as is necessary in place of real numbers. So very useful to keep track of changes within the code. In the next section, we'll be exploring our different types. So remember, this is the type of variable, in this case int. So exploring all the different primitive types available to us in Java and what kinds of values they can hold. Now that we have an understanding of what variables are and how to use them, let's look at some of the types available to us. So if you remember, in a variable declaration, we of course have to give each variable a type. Now that type of variable cannot change once it's assigned, so we need to be sure to assign it the right type to begin with. So we can assign it one of the primitive types available to Java, or we can create a type of our own. So we'll be talking about creating types later when it comes to talking about classes. But for now, let's just focus on the 8 primitive types that are already built into the Java language, and we'll add a 9th to this list, which is going to be strings. Now strings aren't quite a primitive type, but we'll treat them as such for now. So let's just make some comments. So 8 primitive types of variables. Okay, and these are bytes, shorts, ints, longs, floats, doubles, characters, and booleans. And actually, I'm going to shorten this to chars as we usually refer to them as such. Okay, we'll also add the 9th. So 9th primitive type is going to be strings, but they are not technically the same as the other 8 primitives. Now let's focus on grouping these 8 primitive types and 9 including the strings. So from now onwards I'm going to group strings in, so I'm going to call it the 9th primitive type, but just be aware that it's technically a little different. So we can explore the differences once we introduce classes again. So we'll start off with the numerical types, which are going to be these first 6 here. So numerical types are going to be bytes, shorts, ints, longs, floats, and doubles. Now, why do we have so many different numerical types? Well, for a start, these first 4, so bytes, shorts, ints, and longs, these all represent whole numbers, okay? So they cannot represent decimal numbers at all. If we want to use decimal numbers, we have to use either floats or doubles. That being said, floats and doubles can represent whole numbers as well, but if you want to get technical, they take up a bit more room in memory. However, as we're not really looking at space and memory right now, as this is again just an intro course, for the most part we're going to refer to whole numbers as ints, and then decimal numbers will use doubles for these. As the need for bytes, shorts, longs, or floats arises, we can introduce them. Just be aware that they do exist and they represent different ranges of numbers. So just to make some notes, we're going to say bytes, shorts, ints, and longs are all whole numbers and represent different ranges. And then doubles and floats are decimal numbers, again representing different ranges. So again, we're going to focus mostly on ints and doubles, and I'm not really going to cover the other 4 types until we need to use them within the code. So some functions or methods take in floats, for example, instead of doubles, and some will take in bytes, shorts, or longs instead of ints. So when it comes time to use those methods or introduce classes that use these different numerical types, we can talk more about them then. But for now, we can kind of treat bytes, shorts, and longs the same as ints, and then we can treat floats the same as doubles. So let's look at some examples of where we might use integers for a start. So ints could represent, again, whole numbers. So a good place would be either age or dates. So use ints, ints for whole numbers, such as age or dates. So for example, we could have int day of the month equals 5, okay? And we'd know that 5 represents the 5th day of the month. Okay, as for doubles, so we want to use doubles for decimal numbers, so such as money. So money is a very common one, as money typically is a decimal number, so we might have $10.50, for example. So double, let's say bank balance, equals maybe we have $500.35 in our bank account. Now one thing to note is if we declare a whole number, the compiler automatically assumes that the whole number is an int. So compiler assumes all whole numbers are ints unless otherwise stated. Okay, and same with doubles, the compiler assumes all doubles or all decimal numbers are doubles. So I'm just going to copy this and paste down here. Compiler assumes all decimal numbers are doubles unless otherwise stated. If we wanted to make a whole number into a double, so let's say we wanted to declare 5 as a double, we could just put the D after it, and then we would tell the compiler that we're referring to the decimal form of 5, or for example 5.0. Okay, so that just about covers the numerical types. Again, all whole numbers we'll call ints for now, and all decimal numbers we'll call doubles. So let's move on to our next type, and before I introduce characters, I actually want to talk about booleans. So booleans represent true or false values. So a boolean can only actually take on one of two values. It is either true or it's false, okay? Whereas an integer can take on a huge range of numbers, and same with doubles. So some places we might use booleans are, for example, a switch. So switch is either on or it's off. Now you could argue that a switch might be halfway on, but technically it's still either in one of those two states. So let's have a boolean is switch on equal to true, and then we could change this to false if we'd like. So it could be false, but it could not, for example, be a 1. Okay. So that's really all there is to talk about booleans, fairly straightforward. We use boolean values a lot when we're testing for logic. So is some condition true? Is this variable equal to true? Etc. Okay, so next we'll talk about characters and strings. So I want to kind of lump characters and strings together because they're kind of similar, yet also subtly different. So think about characters are a way to represent single digit values. Okay, so these can be symbols, these can be letters, these can be numbers. So symbols, letters, numbers, basically anything we want, as long as they're within these single quotation marks. Okay, so for example, character, let's call this semicolon, equals, and we have to open up the single quotation marks here, and then let's put in a semicolon there. Okay, so now if we wanted to ever call on this single character, we could call on semicolon. Similarly, if we had a character 1 that could represent the number 1, okay, as long as it's in quotations. So if it's not in the single quotations, the compiler assumes that 1 is an integer, and so throws us some kind of an error here. One thing to note is that 1, so this number 1 and the 1 in the single quotation marks are two very different values, okay? And we cannot use them interchangeably without converting between the types. So I'll just make a note that as long as between single quotation marks. We can also enter in Unicode codes, such as the code for an @ sign, for example, or the code for, in this case, a semicolon, which is typically a 4-character code. But again, as long as we enter in a \u and then the code, the compiler interprets it as a single character. Okay, so let's talk about strings. Now, strings are useful to represent text or messages within the code. Okay, as long as between these two double quotation marks here. Now, the difference between strings and characters is that characters are only ever 1 digit long. So if we try to make this a few digits long, we get this compiler error here. It can only be 1 character long, whereas strings can be as long as we want. They can be actually empty if we'd like, so they can contain no characters, or they can be 1,000 or even 1,000,000 characters long. So for example, let's create a string, and notice how string is different from the other types in that it is the word string is actually not blue like the other types, and we have to capitalize the S here. Okay, so string, let's call this mammoth, and we'll set this equal to mammoth interactive. Now, although this is 2 words, because both words are encompassed between the 2 double quotation marks, this is considered to be just 1 string, so 1 value. Typically, any kind of text input we intake will be interpreted as a string. Okay, so that's why it's useful for text. Similarly, any messages we print to the console or to the terminal, those are very often outputted as strings as well. So that's why I also added messages. Okay, so that just about wraps up the 8 primitive types. So again, we have the 6 numerical types: bytes, shorts, ints, and longs. And then we have the decimal types, floats, and doubles. Those are the 6 numerical ones. Then we have true or false values represented by booleans, and single-digit characters as chars or characters. Okay, we introduced the 9th and final type, which is just going to be the string. Now, for the most part, I don't usually use characters that much. I find myself using strings more because there's a lot more that we can do with strings. I was going to cover conversion between the different types in this section, but just to save a bit of time, I think I'll cover that when it comes time to do so. Okay, so the conversion process is actually quite easy. Typically, we just call on our variable name and then pass whatever we want to convert to. But again, I'll get more into detail with that later. Okay, so we've covered what variables are, how to use them, and the types. I think it's safe to say we're ready to move on to the next section, which will be arrays, and I'll be coming right up.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy it before the sale ends. Thanks for watching, and I'll see you in another video.